Here we have a SAT math problem. Okay, let's cover the question. F of x equals to a times x negative b the whole square positive 10. In the xy plane, the graph of the function f above has the x-intercepts at negative 2 and positive 6. What is the value of a? Okay, in the given quadratic function over here, we have to get the value of the constant a. Actually, the given quadratic function is in vertex form. That is f of x equals to a times x negative h the whole square positive k. So this is a vertex form of a quadratic function. Okay, in this quadratic function, if I want to get the vertex, let me write the stuff over here. What I have to do is I have to consider the value over here, which has been subtracted from x. So that is h. This h represents the x coordinate of the vertex, and the value over here at the place of k represents the y coordinate of the vertex. So h comma k is the vertex of this quadratic function. Okay, here at the place of h we have b in our quadratic function. So this b represents the x coordinate of the vertex. Okay, here if I want to get the x coordinate of the vertex, there is an idea. That is, we have to consider the given information. That is, the graph of the given function f has two x-intercepts, negative 2 and positive 6. When I find average of these two x-intercepts, that is equal to the x coordinate of the vertex. Now to get the x coordinate of the vertex b, we have to find the average of these two x-intercepts. That is, we have to add them and divide by 2. So here 4 divided by 2, that is equal to 2. Okay, here I got the value of the x coordinate of the vertex, and that is the value of b. And also, whenever we have a function like f of x or g of x in an xy plane, this f of x represents the y coordinate. So that is, we can consider y instead of f of x over here. So now we can rewrite the given function as y equals to a times x negative, and for b we can plug in this value 2, that is x negative to the whole square positive 10. Okay, here to get the value of a, we need to plug in one of the points on the graph of this function. Okay, here we have the two x-intercepts at negative 2 and 6, and we can write them as points. When I write these two x-intercepts as points, I am getting negative 2 comma 0, and the other one is 6 comma 0. Because at x-intercepts always a y coordinate is 0. Since the graph of this function has these two x-intercepts, the graph of this function passes through these 2 points. So what we can do is we can plug in one of these 2 points into this equation to get the value of this constant a. So let me use a second point over here. So whatever point I use, I'll be getting the same result. Let me use a second point. That is, I have to plug in this x coordinate 6 for x over here and y coordinate 0 for y over here. Then I'm getting 0 equals to a times 6 negative to the whole square positive 10. 0 equals to a times 6 negative 2 is 4, that is 4 square positive 10. Okay, let me continue over here. 0 equals to 4 square is 16, that is 16a positive 10. Okay, here let me subtract 10 from both sides of this equation. This positive 10, negative 10 will cancel out. Okay, here when I combine 0 and negative 10, I'm getting negative 10 on the left side. On the right side, I'm getting 16a. Let me divide both sides of this equation by 16. This 16 will cancel out. Here 2 goes into 10 5 times, 2 goes into the 16 8 times. I'm getting negative 5 over 8 on the left side, on the right side a. Okay, here I got the value of a. Its value is negative 5 over 8. We find this value in answer choice B. The correct answer choice for this question is B.